This is Covalent Bonds and correlates with Chapter 6.3 in your textbook. Your key concepts for this video are: how are atoms held together in a covalent bond? What are the properties of a molecular compound? And how do bonded atoms become partially charged? So last video we learned about ionic bonds. And in ionic bonds, the ions are attracted together because of their opposite charges, which they get because of giving or taking valence electrons. However, in covalent bonds, atoms are held together because they share valence electrons. Covalent bonds form between non-metals. Now let's look at these two fluorine atoms here. Both of them have 7 valence electrons, so neither one is going to be willing to give up one of its valence electrons to make the other happy. So instead, what they're going to do is they're going to share that one valence electron each, so they both end up getting 8 valence electrons. These shared electrons will revolve very quickly around both nuclei, so quickly that it seems like both of them have a full valence shell. So this right here, where both atoms are sharing 1 valence electron each, that's called a single bond. You've got a double bond, where each atom shares 2 of its valence electrons, and you've got a triple bond, where each atom is sharing 3 of its valence electrons. So let's talk about what are the properties of molecular compounds. First off, you might be thinking, molecular compounds, I thought we were talking about covalent bonds. A molecular compound is the name for atoms that are held together by a covalent bond. So whereas ionic bonds make ionic compounds, covalent bonds make molecular compounds. So on to the properties. Just like how nonmetals have the opposite properties of metals, molecular compounds have the opposite property of ionic compounds. So, first off, they have low melting and low boiling points. Remember, sugar melts at 186 degrees Celsius, whereas salt, which is an ionic compound, melts at 801 degrees Celsius. They're also poor conductors of heat and electricity, so we use them as insulators. And overall, covalent bonds are weaker than ionic bonds. So, how do bonded atoms become partially charged? There are 2 types of covalent bonds. The first is one we call nonpolar. These are bonds in which the electrons are shared equally by both atoms, kind of like these 2 dogs carrying the stick. So this gives the overall molecular compound a neutral charge. Now, the other type of covalent bond is a polar covalent bond. This is where the electrons are not shared equally between the atoms. So one atom pulls on the electrons more than the other. So like in water, the atom of the oxygen is much, much bigger than the atom of the hydrogen, which is little. So the oxygen pulls on those electrons stronger than the little hydrogen, so oxygen ends up with a slightly negative charge, whereas hydrogen ends up with a slightly positive charge, which is why we say water is polar. Now, naming molecular compounds is a bit similar and a bit different to ionic compounds. So first, the differences. In a molecular compound, you need to use a prefix to represent the subscript. So, if you see the prefix mono, you know that the subscript means 1. Di means 2. Tri, like triangle, means 3. Tetra means 4. Penta, like a pentagon, is 5. Hexa, like a hexagon, is 6. Hepta, 7. Octa, again octagon, 8-sided, 8. Nona, 9. So here we have CO2. So carbon dioxygen, because there is 1 carbon and 2 oxygens in the compound. You might be thinking, Ms. Cords, shouldn't it be monocarbon dioxygen since there's only 1 carbon? Well, when the first element only has 1, you don't put the prefix. So it's just carbon dioxygen. And lastly, just like ionic compounds, you need to change the end of the last element to "ide" to show it's part of a compound. So we have carbon dioxide. So now that you know how to name them, let's figure out how to represent the molecular compounds in a chemical formula. In general, you would just have the name, and based on the prefixes, you would know what it is. So here we have dioxygen difluoride. So di means 2, so we have 2 oxygens and 2 fluorines. So we have O2F2. Please note that in ionic bonds, you would be able to simplify this to just OF, but in covalent bonds, you can't because then you would have oxygen monofluoride, and that's a completely different thing. So you cannot simplify the subscripts in covalent bonds. And you can actually always check this with your Lewis dot diagrams. So you could draw out oxygen and water. Oxygen has 2 blank spaces, hydrogen has 1 blank space. So you need 2 hydrogens to balance out 1 oxygen, and they can share these ones here, and you would end up with H2O. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.